All right, today we are going to be moving on in Unit 6 to Lesson 6.3, and we'll be talking about medians and altitudes of a triangle. So in a triangle, a median is a line segment with endpoints that are a vertex of the triangle and the midpoint of the side that's opposite the vertex. So every triangle has three medians that are concurrent, and the point of concurrency of the medians of a triangle is called the centroid, and the centroid is always inside the triangle. So the centroid theorem says that the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Now, all polygons have a balancing point, or center of gravity, and that's the point at which the weight of a region is evenly dispersed and all sides of the region are balanced, and the centroid is the center of gravity. That's how you find where the balancing point for a triangle is. You find the centroid. So let's see how this plays out. In triangle ABC, point P is the centroid, and we are told that segment BL is 6 units long. So we're asked to find BP and PL. Well, I know that BP is equal to 2/3 of the length of BL because of the centroid theorem, because the centroid is 2/3 of the distance from the vertex to the midpoint. So because BP is 2/3 of BL, so we can substitute in what we know BL to be, which is 6, and do 2/3 of 6, which is 4. So now that I know that BP is 4, I can use that to prove what BL is, because I know if BP is 4, and BP plus PL is 6, so 4 plus PL equals 6, so 4 plus what equals 6? It'd be 4 plus 2. So that means PL has to be 2. So let's try to do another one on together here. In this triangle ABC, Q is the centroid. Segment BE is 9. So we're asked to find segment BQ and QE. Well, BQ is going to be 2/3 of BE. And I know that BE is 9 units long. So BQ then is 2/3 of 9, which is 6. So put a 6 there. Now, QE plus BQ equal BE. That's the segment addition postulate. So I can substitute in what I know. I know that BQ is 6, and I know BE is 9. So if I subtract 6 from both sides, I get that QE is 3. So that's really all there is to this postulate, knowing that 2/3. Now, in this triangle, LMN, we're told that PY, the little short side here, is 7 units long. We're asked to find LP. Well, because LX is congruent to XM, that means that X is the midpoint of LM. And NX is a median because it goes from a vertex to a midpoint. Likewise, Y and Z are the midpoints of MN and LN, respectively. So segment LY is a median, and so is segment MZ. And therefore, point P is the centroid. So the centroid is where the medians intersect, and point P is the centroid. Now that I know that once that is a centroid, 2/3 of the distance of the entire length is going to be the distance from the vertex to the centroid. So LP is going to be equal to 2/3 LY. Now that means that I can break LY up into its pieces, LP and PY. So LP is equal to 2/3 of LP plus PY. And I can distribute or substitute in what I know PY to be, which is 7. And then distribute the 2/3. So 2/3 times LP is 2/3 LP, and 2/3 times 7 is 14/3. And then I can subtract 2/3 LP off of both sides. And LP minus 2/3 LP leaves me with 1/3 LP. So 1/3 LP equals 14/3. And then if I multiply both sides by 3, I just get rid of the thirds thing, and LP is equal to 14. So then I can prove that is 14. quicker way to do that is if I know the short side of the median, then I can find the longer side by just multiplying the short side by 2. And I can work the inverse of that as well, the converse of that. If I know the long side was 14, I could just divide that by 2 to get the short side of 7. So in triangle XYZ, SP is 3.5. 3.5 is the short side. So to find PZ, the long side, I just need to multiply that by 2. So PZ is 7. All right. Now, to find the altitude of a triangle. It's very important to know the altitude of a triangle because that's how we find the height of a triangle. And that's how we find the area of a triangle. So the altitude of a triangle is a segment from a vertex of the triangle to the line containing the opposite side, and it is perpendicular to that side. An altitude can lie in the interior, in the exterior, or on the side of the triangle. Every triangle has 3 altitudes, and if you extend them out, the altitudes of a triangle are concurrent. The point of concurrency is called the orthocenter. The lines containing altitudes segment AF, segment CD, and segment BG intersect at P, which is the orthocenter of triangle ABC. So this diagram on the right here, P is the orthocenter. That's where the altitudes meet. Okay, so we can find an orthocenter on the coordinate plane by finding the slope of 2 of the sides, and then finding the slope that's perpendicular to those, and then finding an equation for those, and then solve the system of equations. So the slope of AC is, we can count, we go down 3 and to the right 2, so the slope of AC is negative 3/2. And the slope that's perpendicular to AC is the opposite reciprocal of negative 3/2, so that is 2/3. Now, to find the equation of that line, it's going to go through point B, and it's going to have a slope of 2/3. So it's going to look like that. Well, I don't know the exact equation of that line, so I'm going to have to do some algebra to figure that out. I'm going to use the point slope form. It goes through point B, so it goes through negative 2, 4. So y minus 4 equals 2/3 x minus negative 2, in other words, plus 2. So y minus 4 equals 2/3 x plus 4/3. Oh, I forgot that bar there. And then we're going to add 4 to both sides. So 2/3 x. 4/3 is the same thing as 12/3, so this is 16/3. So y equals y equals 2/3 x plus 16/3. And if you look at the line that we drew, 16/3 would be the y-intercept. 16/3 is the same thing as 5 1/3. So that does work. So we're good with that. Next, the slope of line BC. Well, if you look at side BC, it has a slope of 1. And the slope that's perpendicular to 1 is negative 1, because it's the opposite in the reciprocal. So it's going to go through point A and have a slope of negative 1. Well, actually, I don't have to do any algebra for this one because I can see from the graph that the y-intercept is 4. So my slope is negative 1. Y-intercept is 4. So that is the equation of that graph. Now, where those points intersect is somewhere between negative 1 and 0 for the x, and somewhere between 4 and 5 for the y. Now, I don't know exactly where that is, so I need to solve the system. So in order to do that, I'm going to use substitution and just set these two things equal to each other. 2/3 x plus 16/3 is equal to negative x plus 4. If I add an x to both sides, that makes it 5/3 x. And then if I subtract 16/3 from both sides, that becomes negative 4/3. And then if I multiply both sides by 3/5, that will cancel out the 5/3. So x is equal to, those cancel out, negative 4/5. So our x where they intersect is negative 4/5. Now I can find my y by just plugging that negative 4/5 into either one of my original equations. So y equals the negative of negative 4/5 plus 4. Well, the negative of negative 4/5 is positive 4/5. So our y is 4 4/5, or we could say 24/5. Now 4 4/5 is between 4 and 5. Negative 4/5 is between negative 1 and 0. So if you look at our point of intersection, it does make sense that that would be the coordinates of our orthocenter. So that is how we find the orthocenter. All right, so if you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as quickly as I can. Have a great day.